Okay, in this video, we will be focusing on polymorphism. Okay, and what is polymorphism? Well, polymorphism is when we write a program such that different types of objects receive the same command, but they act differently according to their type. For example, see in the picture here, I can write my program such that my object, this is it of the object, okay? I have each object here being an animal, alright? But I define them, well, I define the actual class of each one as subclass of animal. So I can define cat that inherit from animal, a dog that inherits from animal, and a duck that inherits from animal. And I can define a common command or common method, speak, alright? I can define speak in animal, and then I can, well, in cat, in dog, and in duck, I can define its, well, their own speak method. Okay? So, when I actually use an animal, alright, maybe I'll have a variable that is an animal, but I don't know whether this is a cat or a dog or a duck, alright? But I don't really need to know, alright? Sometimes you need to know, but in other times you don't need to know which specific animal that is, alright? And you can still order the animal to speak. Like this, call the speak method. Alright? You can call animal.speak, and it will, well, the execution will actually go to execute the speak method specific to the animal. So if X is actually attacked, X.speak will actually execute the speak method of the cat. But if X is a dog, then X.speak will execute the speak method of a dog. Alright? So, this is polymorphism. You can supply the same command, speak, to a generic object or generic variable. And it will execute the specific code according to the specific subclass that we actually use to make that object. Okay? So, common command can be used, and the correct instruction will be chosen by the system. Alright? So, that's writing polymorphism. Okay? Let's see an example in more detail. Right, let me end this slideshow first. Right, so in this package, right, I have class animal, which I write here. Alright, it's a class that has a method speak, that returns string of, well, actually, it returns an empty string. Alright, speak that belongs to class animal return an empty string. Alright. And I have to define speaks such that the system knows that any animal has method speak. Okay? So that when you call speak for cats, for dogs, it can know that, okay, all animals have speak. And then next, I will have to call the correct speak of that particular animal. Okay? Right. So what about cat and dog and duck? So cat extends from animal. That means cat is regarded as an animal, and cat has its own speak method, which returns meow. Alright. Similarly, for dog, right? For dog, it also has speak method, returning woof. And for that as well, its speak method return quack. Okay? And all duck, cat, and dog extend from animals, so they are regarded as animals. Okay? So, in the actual use, alright, once we define cat, dog, duck, and animal, our program that actually use the speak method can be something like this. Alright, so let's see what this program does. Alright, I create variable A and B, being an animal. Alright, B also an animal. And the actual object that get created for A is a cat, and for B is a dog. Alright, so you can create a variable of the superclass type. Alright, and the variable of the superclass type can store the object of the subclass type. Alright, that means variable A, if I define it as animal, it can store cat, dog, and duck. Alright? And B as well. It can store cat, dog, and duck. Okay? So, after I assign cat to A and dog to B, I try to print what it speak. Alright? So A calls speak method and B calls speak method. Alright? Which, well, A is an animal. Alright? But the actual object is a cat, so it should meow, right? And the dog, it should woof, right? And the next part, I swap A and B. Alright? A can store dog as well, since it's defined as an animal. So I can actually swap the content between A and B. Alright? And once it's swapped, when I call it a speak, it should say wolf, right? And it should say meow for B. Alright? So, well, what happened here is actually something like this. When we first originally have a being an address, right? A is a variable storing an address, which I use an arrow to represent, right, an address of a piece of data that is of cat type. And the second line, B, is actually an address that stores a memory block that contains doc information. Alright, so originally in the first 2 lines, we have something like this in our representation in the machine's memory. Alright, and when I create C equal to A, what happened is a variable C is created and its address copy the address of A. That means it refers to the same location because address is just a number that represents a location. So C becomes equal to A means C points to or store the same address that A stores. Then A becomes equal to B means you change and A now is storing the same address as B stores. Alright? And then B equal to C means B no longer stores this address, but stores the same address that C stores. So the effect is that O now no longer remember the address of cat, but it now remember the address of dog, and B now remember the address of cat instead. Alright? So if after the change, A will, A.speak will return wolf, and B.speak will return meow. Okay? So that's what happened. Alright? So polymorphism is when we define a type. When we define A to be a common type, right, or use a superclass such that A can store more than one subclass. Alright, we might not need to know which kind of object, cat or dog or duck, that A stores. But when we call A.speak, it will execute the correct one. Okay? So the user doesn't need to be concerned whether it will call the correct one. The system will do the work for you. Alright, but you initially have to be able to specify the superclass to use as the common type for your variable. Alright? So this is polymorphism. Alright? Same code. That is speak. Different action. Different action for each speak depending on the subclass. Okay? Right. So that's it. Alright? We'll continue in the next video.